In this mini lesson, we're going to look at what scientific notation is. Your objective is you can express and manipulate chemical activity quantities and scientific numbers using scientific conversions and mathematical procedures, including scientific notation and significant figures. The question for this process is, how does scientific notation make working with very large or very small numbers much easier to manipulate? So, scientific notation allows us to express very large or small numbers in a more convenient way. So if I have 15 billion, I can express that without writing all 9 of those zeros. I can express that 1.5 times 10 to the 10. Same thing with 0.00026. I can take that and express it in 2.64 times 10 to the negative 6. When expressing numbers in scientific notation, always keep the same number of sig figs as in the original number. So in that first number, 15 billion, we can see that there's 2 significant figures. So I have 2 significant figures in my scientific notation. In that second number, I can see that I have 3 significant figures, so I'm going to keep 3 significant figures in my final notation, scientific notation. So, to express a number written in standard notation into scientific notation, we're going to move the 0 until non-zeros digits appear to the left of the decimal place. So we have 1 non-zero left at the end of the decimal place. The exponent represents the number of decimal places you have moved. A positive exponent represents a larger value than 1, and the negative represents a value less than 1. So all significant figures seen in the original number. So we keep all of them. We want all of them. So if I have 150,000, I'm going to make sure I have those 2 significant figures in the front of my number. So let's do some examples together. So we're going to write the first number in scientific notation. I have 4,089,000. I want to write that in scientific notation. So 4.89 times 10. Now I count. 1, 2, 3, 4, 5, 6 times 10 to the 6. This number down here, these are my significant figures. I've got 3. So 2, you can't see my decimal place, 0.16 times 10. I count. 1, 2, 3, 4, 5, 6. Is that number bigger or smaller than 1? -6. Here, let's do this last one. These are my significant figures. Remember that 0 counts, so 5.3201 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11, because that number is bigger than 1. So let's do a couple of these backwards. I have 0.9 times 10 to the negative 3. So I'm going to go backwards 3. 1, 2, 3. So 0.1, 2, 3. 9 would be my answer. Here, I'm going to go forward 5, so 837, so 1, 2, 3, 4, 5. Here, it's just 4.0. Here, we're going to move it 1, 1. So you can do the bouncing method where we bounce, or you can count when you add the zeros. So I'm going to let you do some practice. All right, so here's a couple of rules. To add or subtract quantities in scientific notation, the quantities have to have the same exponent. So your exponent here has to be the same. If two quantities are expressed to a different power of 10, you must change one or both quantities so they're expressed similarly, or the same power, before you do that. So if we look at this one, I have to change it, right? So let's go back to, so I would have 245 times 10 to the 12 plus 4 times 10 to the 12. So if I add these together, my final answer would be 2.49 times 10 to the 14. Right, because we add these together, and then we only want one number in front of that decimal place. So, to multiply and divide in scientific notation, the quantities written in scientific notation, the quantities do not have to have the same exponent. For multiplication, you multiply the first factors, then add the exponents. For division, you divide the first factors and then subtract the exponents. So if I multiply these two together, I have 8 times 10. I add these, right? 26. Right. That's all for this mini lesson on standard notation and scientific notation.